okay? And the media support is 4.79, right? Okay, there's some difference, right? And after you square it, you know, normally the difference should be bigger, right? Okay. However, for you, maybe you think the variance is different, right? Just slightly different. But after the 11th test, actually is the statistic tells the 11th test told you actually the variance is not that significant different from each other. It's okay. Even you square it, you still consider it's not that not big. For example, if like here, for example, if it is 10, or this is like 3 or 4, I think it will be different. The difference will be significant after the 11th test. Okay. You observe some difference here, but after the statistical test, 11th p-test, it's not significant. It's okay? Maybe I just explain to you again. So I think in 11th test, usually we look for F value, right? But F value is something you're not interested in. Always you're interested in the significance value, right? Significance, right? So sig means P. Significance means P, okay? So you always look at significance. You just ignore this, okay? All right? For example, like a T. Actually, we are not in, you know, if the T is bigger than the critical T, usually it will be significant, right? It's the same. If the F is bigger than the critical F, you know, but here it's not, that means F here is smaller than the critical F, okay? That's why it's not significant, right? Okay, now remember null hypothesis means there's no difference, right? So if the P value is bigger than 0.05, then we accept null hypothesis. So when you accept null hypothesis, that means the variance of the two groups are equal. Is that okay? You understand? So that's why we use the top values. But even if you use this one, you know, because eventually you're only interested in the P, right? Like here, so it doesn't matter. Excel, you know, also I showed you there's no difference. But in SPSS, you see some minor difference, like here, like this 2T. You know, difference is really small, right? It's okay? All right. So, have I answered your question? Partially. Well, it doesn't matter. I think it will take you some time to digest, okay? Right, okay. But anyway, just remember, if 11 P is, just remember, okay? If you forgot, just go back to this slide, and then you understand what it means, okay? Okay. All right. And also, remember last week, I introduced you the book, a wonderful book, do you still remember the name? SPSS for Psychologists. If you buy this book or borrow this book, okay, actually it will explain to you everything, like what I have explained to you today. Okay? So just remember the rules. Then you remember how to perform statistic tests and how to interpret the results. Right. All right, so because 11 P is bigger than 0.05, so we assume there's no difference in variance. So we assume there's equality of variance. So we use the top row of values for T, okay? All right. If like here is smaller than 0.05, then we use the bottom row. That's all, okay? That's all you need to remember. So you report, the difference this way, okay? Actually, you know, in writing a research article, you know, you just remember, okay, finally how do you report it? Of course, you can change the word slightly, change the wording slightly, but basically this is how they're going to report the significance results, okay, test results. Now let's come to our second research question, okay? Now at the beginning of this semester, students were giving an entry test. Now the T would like to see whether there's any difference between the results of entry test and writing performance. So the second research question, this language test score different from essay writing. This means entry test. This language entry test score different from the essay writing. So which test, significance test do we use? Statistical test do we use? So here, the entry score comes from the same participant. Again, we're going to measure the participant again in the writing performance, right? So each participant has been measured twice, right? So which t-test should we use? Paired samples t-test, that's right. So we're going to use paired samples t-test, okay? Okay, you go back to this. All right, so how should you do the test? So you go to, now tell me, analyze, and then where should we, what should we choose? Compare means. And then paired samples t-test, okay? All right, so you go to analyze, you go to compare means, you go to paired samples t-test, you click, and you see this table, all right? Now, pair, remember, you can see that. So that means each variable comes from the same participant, right? Okay, so that's paired, okay? So which two variables should we enter in the two boxes? Entry test, right? Preschool, you don't say entry, but here is entry test. Preschool English test, okay? So you move it to variable 1, okay? So preschool English test, okay? And then you also move what? SE marks to variable 2. Have you done that? Yes? Okay. So what should you do next? What should you do next? Then all you need to do is click on OK. Very easy, okay? You see? Paired samples t-test is here. You see that? Paired samples t-test. Look here, right? Did you get the paired samples t-test results? Yes? Yes? Okay? Yes? No? Yes or no? Yes. Yes? All right, good. So again, let's examine the descriptive statistics. So it shows you, for example, like mean and standard deviation. So which means bigger? Which means bigger? As in mark, right? The performance on writing, is much bigger than the preschool, right? And also the standard deviation is bigger than that, right? It's also bigger, okay? But it's understandable, Sometimes when, the mean is bigger, the standard deviation could also be bigger. It's understandable, right? Okay. All right. So you have to look at this number. It also shows you the pair samples correlation automatically. Remember, correlation measures to what extent two variables can be related to each other, right? But like here, the correlation is 0.8 something. So it's quite high, right? And also look at significance. It's very small, right? So actually you see that they are, so what does it mean then? What does it mean? It means when the entry score tends to be high, the SE mark will also be higher. This is understandable, right? So if you start with maybe if the entry score is something like, maybe like 40, and then in SE marking, SE performance, maybe you will get something like maybe 45. If you got 50 in an entry test, maybe you got 65 in a performance, right? So the higher, the higher. One value is higher, the other variable is also higher, like that, okay? But anyway, I explain to you later, okay? How should we calculate correlation, okay? But here, you should focus on this paired samples t-test. Okay. So all you need to pay attention to is t here, the t. and also the significance, right? P-value. You can see that it's very significant, right? That's all you need to know. That's all. And then you have to report it. See, the T and the degree of freedom and the significance. So report this data. So there was a significant difference between English entry score and writing scores. Report the T and the P. In other words, the LC scores are significantly higher than the entry English scores. Okay? That's all you need to report. All right? So this is easy, right? Okay. So any questions so far? No question? Okay. No question, right? Okay. Now, the teacher would like to know whether there's any relationship between the LC marks and the number of hours spent on LC writing and entry English scores. So here, how many variables do we have? How many variables do we have here? 3, right? LC marks, number of hours spent on LC writing, and entry English score, right? So, which test do we use? Which test? ANOVA, no. Not ANOVA. Okay. Relationship. Do we have 3 groups here? We only have 1 group still. You know, all the score comes from the same participants. The SE marks. Remember, we have 45 students, right? Okay, so we have 45 SE marks. Now, we have already recorded the number of hours each student spent on ISE, so we have 45, numbers, for each student, right? For all 45 students, and also have 45 entry English scores, right? So actually, we have 3 sets of scores, but only 1 group, right? We're going to see the relationship between all 3 variables. So we have to use which test? Correlation test, that's right, correlation test. So, correlation test measures the degree which 2 variables or more. You can actually, in correlation test, you can measure several variables simultaneously, okay? Like 3 or 4 or even 6, 7, 5, 10, a lot, okay? Doesn't matter. So we're going to measure whether 2 variables are related to one another. Usually there are 2, right? Positive correlation. For example, high values of variable x tend to go with high values of variable y. For example, height and weight. Do you agree? Something tends to be high, usually tend to be, heavier. This is not always true, right? But this is a tendency, right? Okay. All the correlation could be negative. To high values of variable x go with low values of y. For example, exercise and weight, right? Usually, if you do more exercise, you lose weight, is that right? So the more exercise, the less weight, right? So it's negative, right? Okay, it's okay. Sometimes could be no relation, no relationship between the 2 variables. Show size and IELTS score, right? There's no relation at all, right? Okay. So basically, Pearson correlation will measure 3 types of correlation: positive, negative, or no. Okay. So we are interested in calculating the correlation, Pearson correlation R. It ranges from -1 to 1. Okay. So for example, like in this case, you can see that when variable 1 is higher, for example, when variable A, is higher, the other variable will be lower, right? So it's negative. Is that right? Is okay? Is okay? Yes. Okay. So you can see kind of a shape like that, okay? And here you can see that 0, there's no relationship, right? Random. So the position of the other value doesn't reflect the position of the other value, right? So no relation, so it's 0. And this is, as a positive correlation, except when, one value, variable 1 is higher, the variable 2 also tends to be high, you can see that, right? So this is a positive, okay. Now usually, we also will look at the absolute value, right? Okay. So when R ranges between 0 to 0.2, weak correlation. When it's weak, usually it's not significant. Usually it's not significant, okay. When R ranges from 0.3 to 0.6, it's moderate correlation. Sometimes it could be significant. And when R is larger than 0.7, strong correlation and usually always, I think, always significant. The P will be always significant, okay? All right. So let's calculate. Okay, so let's go back. Now remember, we're going to test the correlation between 3 variables. Okay, so which 3 variables? Just remember. SE marks, right? And what else? Hours spent on writing and entry test. Okay, that's right. So we go to analyze, and then you go to. Can you tell me which test do we choose? Okay, yes, correlate. And then you choose bivariate, the first one, bivariate, that's all. Okay, so are you on this page? Yes, click on bivariate. All right, it's very easy, just move them one by one, SE marks, hours spent, and then entry test, and that's all. See, a Pearson is automatically selected for you, so you don't need to do anything. Then you click on OK. Then you go back to, you see correlation, right? Now tell me, so you can see that the correlation will tell you, first you can see this, Pearson correlation. The first row, Pearson correlation. So the relation between SE mark and hours spent on SE is pretty weak, right? It's smaller than 0.3, right? Is significant or not? Is it bigger or smaller than 0.5? Bigger than 0.5, right? So it's insignificant, right? Now what about the relation between SE mark and the pre-scoring test? You can see that the Pearson correlation is quite strong. It's more than 0.8, right? And also you can see the P here, the second row. Is very significant, right? Significant, right? Yes? Okay? All right. Actually, this is all you need to know. Right? And then how do you report results? Okay? So this is a result, okay, here. So you can see that when it is smaller than, when the Pearson R is smaller than 0.3, often it is insignificant. And when it's bigger, strong, it should be significant. Very significant, right? Okay. So you can write a test this way. While there's a significant positive, right? Strong correlation between the SE mark and the entry score, you report the R and number of students and the p-value. There's no significant correlation between the SE mark and the hours spent on SE. Okay, right? Yes, this is how you're going to report. This is easy, right? Okay, all right. So do you have any question? Easy. Okay, easy, right? So let's start next, okay? The last one. Now students are divided into 3 groups based on the grades obtained from our comprehensive language assessment, maybe earlier, okay, before. Now the student would like to know whether the grouping will influence the SE marks. So research question 4, will the grouping affect student performance in SE writing? So which significant test do we use? What do you think? And over, because students are divided into 3 groups, right? Okay, and each of them are only measured once, SE writing, right? So we're going to use ANOVA. That's right. So let's go back to ANOVA. Okay, how to perform ANOVA. Let's go back. Okay, so analyze. Okay, now follow me. Analyze. And then which should we choose? Compare means, and then one way and over. That's right. So choose one way and over, okay? Okay, now we're going to put a dependent variable in a dependent list. So which variable should we move in dependent list? SE mark, that's right. SE mark is dependent variable that we're going to measure, right? Okay. And now factor. Factor means what? Independent variable. A factor is independent variable, okay? So which one is the independent variable? Teaching method, that's right. Yes, teaching method, because, oh sorry, no, made a mistake. So SE mark here, grade. Reset, sorry. Grade, because students were divided into 3 groups, right? Different. This is different from teaching method, because teaching method we only have 2 groups, right? Now it's, we further divide them into 3 groups based on the previous language test. You can see that the grade. So 1, 2, 3. I think this is a mistake. Let's change it to 3. Okay, change it to 3. If you see, change it to 3, okay? So 1, 2, 3, that means we only have 3 groups for grade, okay? All right? Okay, and then, yes. So compare means and over. So SE mark and grade. Okay. Should we click OK now or not? Why not? Well, if you click on OK now, so the result you get is very similar to you get from Excel. So you will know that whether the F value, whether the F is significant or not. But because we have 3 groups, you wouldn't know, for example, like each group is significant different from each group, you understand? Because there are 3 groups. So that there are several comparisons, right? If you want, but SPSS does more than Excel, so you can click on post hoc. Post hoc test will be able to, will allow you to find out the specific differences between each 2 groups. Make lots of multiple comparisons of different. So if we have 3 groups, how many comparisons do we have? So group 1 to group 2, right? And then group 2 to group 3, and group 1 to group 3. So at least 3 comparisons, right? Okay. So and you choose this. I don't know why, because I just follow the book. SPS for psychologists. They recommend me to choose this. Okay, so I also recommend you choose that one. Okay, right? And then you click on continue. Okay, and then but there's still something maybe you would like to know a bit more information, which is options. So you can see ANOVA is more complicated, right? Okay, but for simple, to be simple, I just choose descriptive. Just know the mean and derivation, okay? Then you continue. So have you chosen this? Have you, for example, chose post hoc? Bonferroni, yes? Okay, make sure it's ticked, okay? And did you choose options, descriptive? Okay, continue. And then you click on OK. Okay. So you see one way and over here? Yes? Now, okay, so let's see the result, okay? But actually, I think I made a mistake. Actually, we do not only have 3 groups, we have 4 groups. Did you see here? First class, up, second, lower, second, third class. Okay, the reason is here, even I changed some values, from 4 to 3, but actually I didn't change here. If you go to the variable view, you see grade. Grade, okay? You can see that. You can see that. So 1 means first class, 2 means up class. Okay, so I didn't change here, so still there are 4 groups, okay? That's all right? Okay, you can define the groups here, okay? Anyway, okay. So actually we still have 4 groups, okay? So my mistake, okay, right? But anyway, so we have 4 groups, okay? You can see that the first class, the mean is quite high, 72, right? Up second class, 63. Lower second class, 57. And third class, 48, right? So it's very, it's quite certain that the comparison between each group should be big, right? Should be significant, right? Okay. And then you can look at ANOVA test. Remember, at ANOVA, we collect the F value. And also, you have to examine the significance value, the p-value. You see, it's very significant, right? Okay? Okay, and then in the post hoc test, you will see the difference between each comparison. For example, like the first class between up, second class, you can see that the mean difference, it shows you the mean difference, you can see that. So the mean difference is like 8.7, and also, significant or not? Yes, you can see that. Almost everything significant. Everything here is smaller than 0.05. That is a golden value we should look for, right? Okay? Okay? All right, so that means each group of students differ significantly from each other. Is that right? Okay? So that's why we should choose post hoc test to know more details, right? So do you have any questions? Did you get lost? Is it okay? Do you find it difficult to read the values? You get lost? If you get lost, just remember again. Just remember the procedure, how you should. So tell me what questions are in your mind. Is it okay? Do you have any questions? Just for example, looking at the table, is there anything you don't understand? Okay. Anne, do you have any question in your mind?
I don't know how to ask you a question.
So you understand everything I said?
I digest that.
So in which part you're quite, you think the understanding is quite weak? So in which part your understanding is weak? The beginning is easier.
Yeah, but now I lost.
All right, okay. Well, if you think it's too, you can ignore the post hoc test. But anyway, you remember, in ANOVA we calculate the F, right? And also we see whether it's significant or not. You can see that it's significant or not, the p-value. Is it bigger than 0.05 or smaller than 0.05? Smaller than 0.05. That means there's difference, significant difference between the groups. And if you calculate the post hoc test, you will see the detailed difference among the comparison between each 2 groups. Now here, because we have how many groups? 4 groups, so there will be a lot of comparisons, right? So in reading this table, multiple comparisons. So all together, how many comparisons? You can see that. So like 1, 2, 3, 3, 4, 4. So 12 comparisons. So it's similar like it perform maybe 12 t-tests. Okay, 12 t-tests. Okay, 12 independent samples t-tests. Okay. So you can compare. You can consider like each comparison is like similar to an independent samples t-test. It's okay. Okay, and also you can see that the difference is significant. All right? Is it clear? Better to understand? You have no question? Okay, all right. Okay, Actually, if you don't need ANOVA, you can just ignore, okay? Just focus on independent samples t-test and paired samples t-test, okay? I think most of you perhaps will need t-tests rather than ANOVA, okay? But I think it's important for you to understand it, okay? Okay, so maybe let's go through the slides, okay? So remember, in doing, this is a procedure, okay? Even you didn't follow me, it doesn't matter, because actually I provided a procedure, here in the slides, okay? So when you calculate one-way ANOVA, first you have to choose dependent variable. Is there anyone who doesn't understand why should we choose S in mark or not as dependent variable? So dependent variable should be S in mark, right? Because this is the variable we're going to measure, right? So dependent variable. Now factor means grade, because students are divided into two groups based on the grades. First class, second class, right? So 4, okay? So you just input the grade here. And then the post hoc, you can find out detailed difference between each group, between first class and second class, right? Or between the second class and the third class, right? So actually to compare 12, it made 12 comparisons, okay? We choose options because we want to, obtain the descriptive statistics like mean standard deviation of the 4 groups, right? And then in the post hoc analysis, it's optional, okay? It's not a mandatory, okay? You can choose Bufferoni, okay? So you choose Bufferoni to conduct a post hoc analysis to find out which groups significantly differ from each other. Which 2 groups, okay? Which 2 comparisons, okay? Continue, then you choose option, you click option, choose descriptive, then you continue and you click OK. All right, then you click OK here, and then you obtain the results. So you can see that, you know the descriptive. If you didn't click on the option, you wouldn't see this table, but I advise you to see the descriptive statistic first, right? You should see the mean and standard deviation of all the 4 groups, right? So it gives you some information, right? From the observation of the mean, we can pretty sure, right? The difference is quite big, right? Okay. Right. So we conclude that also, in another test. So the grade has a significant effect on students' writing performance. You report the F value, and then 2 degree of freedom. Like this is the between group degree of freedom. This is 42 is within groups, degree of freedom. So indicate the F value. You indicate this significance value, the P value. Okay. But another test does not tell us specifically which means were different from each other, right? Remember, we have 4 means, right? Okay. So in order to find out how the 4 means differ from each other, we need to follow up with post hoc tests, okay? So in the post hoc test, actually, you see more clearly the results, okay? Right? And all you need to do is just look at the significance, that's all, okay? You can ignore all the other, okay? Just focus on this. If it says significant, it's significant. So all the 3 groups, all the 4 groups with different grades have significantly different writing performance. Then you indicate the p-value, that's all. All right? Now, your turn, tutorial. Okay. Now you have to do the statistic test by yourself, okay? Referring to what I have showed you, okay? Now your school had a summer program aiming at improving student English performance. Students are required to provide some basic demographic information, including student ID, gender, TOEFL results. The students were divided into 3 classes, and each class received a different way of teaching. They were pre-tested and post-tested before and after summer program. Now you're going to prepare a report of this program to demonstrate the effectiveness of this summer program with data support. Okay? So we're going to make use of another data set, which I'm going to share with you. Okay? But before you do the analysis, we have to first determine which statistical test we should use. Okay, now look. Is there any difference between boys and girls in the TOEFL English performance? Okay, I already told you the answer. Okay. No, please, but you have to explain to me why. Why should we use independent samples t-test? Girls and boys, so divided into two groups, right? In the TOEFL English performance. So each TOEFL score is different from each other, right? So two sets of scores, right? From two groups. So we use independent sample t-test, right? Okay. Now in general, is our summer program effective? Or in other words, is there any difference between the pre and post-test results? Well, in this case, pair sample t-test, right? Pre-test and post-test, right? Okay? Specifically, which way of teaching is most effective? Remember, how many teaching methods do we have? 3. So if we want to find out which teaching method is more effective, so we compare the final score, right? The post-test score, right? And then they are divided into 3 groups. So we use ANOVA. That's right. So the independent variable is teaching method, dependent variable is post-test, right? Okay. The last. What is the relationship between the TOEFL score and the pre-test score? Yes, Pearson correlation test, right? So now you already know which test to use. Now please, but before you do that, I will share with you the data. Okay. So I'll copy and paste the data, English program, to the shared folder. Okay. So you open this folder, English program. Okay. English program, okay? Yeah. So open it, okay? Just click on English program, you can open it. So are you on this page? How many of you are on this page? Did you open the English program data?
Yes.
Okay. If you have any problem,